Hello and welcome to Lesson 4.1. Lesson 4.1, we're talking about quadratic functions and their transformations. This is found on pages 194 to 201 in your books. Starting off with some vocabulary, we're first going to talk about quadratic functions. It's in the form, the general form, right here, f of x is equal to ax squared plus bx plus c. That's the general form where a, b, and c would be actual numbers. And you can see that below. I gave you guys an example where it's d of x is equal to 3x squared minus 7x plus 12. So this is what a quadratic will look like this. Now, it can have all of those pieces, or it can have some of them, but it needs to have this first piece, this x squared piece, to be quadratic. If it doesn't have the x squared piece, it's not quadratic. But it could also look like, let's give another function name. Let's call it, I don't know, e of x is equal to 3x squared plus 12. This is also a quadratic function. Now you notice we're missing that middle term, that negative 7x term, but it's still quadratic because it still has the x squared on it. And just like that, we could have one, I could call it, let's say, m of x is equal to, how about 3x squared minus 7x with no 12. And then it could also just be 3x squared. It would also be quadratic. Those are all examples of quadratics. So a quadratic function has a special type of graph, and that's called a parabola. It looks like parabola, but it's parabola. That's the shape of a quadratic function. Now you see one here, right here, and it's this U shape right there, that U shape. That U shape can be facing up like it is now, or down. Oops. Or down like that. However, it cannot face sideways. That's a no-no. No sideways. Or it cannot be at an angle. It's either straight up or straight down. Now, a lot of times I think you'll hear me talk about this as being a U or an N. Is it a U or upside down U? And we'll talk about more about what makes one or the other here in a little bit. Alright, next we're going to be talking about vertex form. Vertex form is f of x equal to a, parentheses, x minus h, in parentheses, squared, plus k. Vertex form is nice because it's very easy to graph. And it's not too difficult to work with, so it's very easy for graphing by hand. And these parabolas will have an axis of symmetry. Now, we all know what symmetry means. It means, you can fold up a shape and it's equal on both sides. Well, the parabola shape looked like this. If you notice, if you take dotted line and you fold it right there, it should line up on top of each other. Now, obviously, my drawing isn't that good because I don't draw very good, but it should. So that's the axis of symmetry. In vertex form, the axis is where x is equal to h. Right. This dotted line is a vertical line, which means it's going to be an x equals line. It's going to be x equals whatever that h is. And that's going to tell us where the axis of symmetry is. Next is we have a vertex. Now remember, a vertex is a corner, right? It's a corner. Now here we don't have an obvious corner. It's kind of a rounded corner, but we still call it a corner. And the vertex of the parabola is at hk. Now we have an h here and a k here, and that's where we get the vertex from. All right, now let's bring this down, and let's try it with this one. Now I named this one m. This function's name is m. M of x is equal to 2 parentheses x minus 3 end parentheses squared minus 5. So let's first figure out where the axis of symmetry is for this one. All right. Well, we know that axis of symmetry is going to be where x is equal to h. Well, in this case, h is right here, which is 3. So the axis is going to be where x is equal to 3. Now, one thing that lots of people like to do and try to do is say this is a negative 3 because of this negative sign here. Well, there's a negative sign up in the general form of it. So we kind of need to think about is it always being the opposite of what it says in there, right? So this says a minus 3, so here's going to be a positive 3. If this was a positive 3, this would be a negative 3. They're always going to kind of be flip-flops, so that's something we have to remember. All right. And then, so that's the axis. The next thing we want to talk about is the vertex. Vertex. Well, the vertex is always going to be at hk. Now again, all right, it's going to be the opposite of this number in here, which is it's a negative 3 inside of there, so it's going to be a positive outside. So we have a positive 3. And then we look at the k out here is a minus 5. Now that one actually translates exactly, so that one's still negative 5. Right? Because if you notice up here, it's a plus 5, or plus k. So down here it should be a, that negative sign is going to travel with it. All right? And so that's where we get the axis and the vertex from. All right, moving on. Now, a parent function is the most basic type of an equation. It's the very most simplest. The parent quadratic function is f of x equal to x squared. All right? There's nothing out here, and there's no a value in front of it. It's very simple. It's just the x squared. It's the basic parts that we need. Now remember I said that we need that squared to make it a quadratic. Well, that's basically all it has. It has just enough to make it a quadratic and no more. So that's the basic type. And this graph here, this is the parent parabola. All right. You'll notice it's facing up. It's got a vertex at 0, 0. And then some things we can think about is this graph, well, it really comes from this place right there. So if I take 1, what's 1 squared? Well, 1 squared is 1. If I look at 2, what's 2 squared? Well, 2 squared is 4. If I look at 3, 3 squared is 9, and so on. So it really kind of comes from the math there. All right. Now let's look at this first problem. And we're going to be graphing in the form of ax squared. So it's the parent function added just a little bit. We're going to add that a value in there. All right, so it's the parent function plus just a little bit more that we need to deal with. Now, on this graph here, we have the parent function already. Remember, there's 1 squared here. 2 squared is 4. 3 squared is 9. So we have all those pieces there. So now we want to figure out what the graph of 1/2 x squared is. Well, we haven't learned any tools yet, so basically the only way we can do this, and we can do this with any function, is make an xy table. Now, what I would suggest doing is go 0, 1, 2, and 3. Because there's a 0, 1, 2, 3 on this graph. And then the second half over here, well, that's just going to be a mirror image, right? You see how these are mirror images? The right side is the same as the left side, right? So since those are mirror images, we can just flip it over once we graph this half. So let's put in 0 in here. So I have 1/2 0 squared. Well, that's going to be 0 because there's a 0 multiplied out is 0. Let's put in 1. We have 1/2 1 squared. Well, 1 squared is 1. 1/2 times 1 is 1/2. Plug in 2, we get 1/2 2 squared is equal to. Now remember, we need to do this operation here first. Alright, so 2 squared is 4, half of 4 is 2, and last is 1/2 of 3 squared, which is 3 squared is 9, 1/2 of that is 4.5. So, if I'm going to come over here and I'll graph this in, I'll say green. Well, at 0, it's still 0. At 1, it's 1/2. So let's try to make this as neat as possible. At 2, it's 2. And at 3, it's 4.5. If I take this and there we go. And that is our graph of 1/2 x squared. Now, doing it this way is something we could do every time, even if we don't know how to graph something through different types of tricks and stuff like that. But if we look at what we've done here, is we've taken the parent function, which is this black line, and we've cut it in half. So basically, if I look at any place on this graph, let's look at 3 here. Right. At 3, it used to be 9 tall. Now it's only 4.5. So I cut it in half. I cut 2 in half. So basically what I'm doing is this A value is in charge of either compressing the graph down, making it shorter, or if the A value was larger, a big number, it would stretch it up. So either you think about it as being shortening or compression, or stretching. And this is basically what I just touched on about the compressions and stuff like that. What this does is it gives us a little bit more information. It says the A value, and the A value in our equations is very important. And our A value for vertex form is right here. A parentheses x minus h squared plus k. See, our A value is right there. A value is very important when graphing quadratics. It tells us how narrow or wide the graph will be, or if it is facing up or down. Now, remember at the very beginning I told you that they could be facing up or down, and now we're just kind of touching on that. Alright, so if A is positive, a positive number, it'll be facing up. A negative one, it'll be facing down. So I have 3 examples right here, and let's look at each one and see which direction is going to be facing, either up, and this is considered facing up, or facing down. That's considered facing down. Alright, so let's look at the first one here. Y is equal to negative 0.5, parentheses x minus 5, parentheses squared, plus 3. So the only thing that changes this is the A value, which is right here. And the only thing that we need to look at is it positive or negative? In this case, it's negative, which means it's going to be facing down. Right. If you look at this one right here, this one looks a little bit different. There's no parentheses, and excuse me, no parentheses, but the A value is 1/3, and that's a positive number, which means it's facing up. And the last one, g of x here, the A value is 12, which means it's facing up again. Now, we also talked about wider and narrower. Right? So if we look at the absolute value of A, which just means I don't care about if it's positive or negative, I'm just looking at the magnitude of this number. If it's between 0 and 1, that's numbers like 1/2, 0.3, 1/4, numbers like that. If it's between 0 and 1, the graph will become wider than the parent function. Now we saw that in example 1, where it was 1/2 and it became a shorter, wider graph. If the absolute value of a is above 1, the graph will become narrower than the parent function. And I would really like to think of this top one as being the compression, which means it's going to get smaller, and this bottom one as being a stretching, making it taller, so shorter and taller. Looking down here, this first one, is it going to become narrower, or is it going to become narrower or wider? Is it going to become a stretch or compression? This one here, it's 0.5. 0.5, that's going to be a compression. Alright, which means it's going to be becoming wider. If you want to think about it as being shorter, those are all ways to think about it. The middle one, number 2. The a value is 1/3. This one's going to be compression again. It's less than 1. And g of x, the a value is 12, which is larger than 1. So this is going to be a stretch. Okay. Problem 2, we're going to be graphing translations of, and that f of x is a parent function, right? It's the most basic type. Now if we look at g of x here, it's like the parent function. The only thing is we have this minus 5 on the back. So it's like the parent function, but it's a little bit different. Now, what these ones do when they are on the end here, if they're outside of the x squared, then what those are going to be controlling is our up, down. Alright? Up, down. And this one works exactly like you think it would. If it's a negative, it's going to be going down. If it's a positive, it's going to be going up. In this case, it's a -5, so we're going to be going down 5 units. So from 0, I'm going to be going down 1, 2, 3, 4, 5. And that's going to be my new vertex. It's going to be my new bottom part of my graph. Right? And basically what we're going to be doing here is making everything happen the same. So I can make it the same shape and everything, which if I look here, it goes over 1, up 1. So here I'm going to go over 1, up 1. And then we go over 2, up 4. So I'm going to go over 2, up 4. And then try to make that a nice... And remember, it's symmetric. So draw the other side the same. Alright. Good, so that's what we do on the outside. So outside controls left, right. Now, here I have one on the inside. You might be thinking, what does this one do? Well, if you thought about the last one controlling up, down, if it's on the inside, it's going to be controlling right, left. Now, this one's going to be backwards of what you would think. It's going to be kind of like the beginning when we talked about the vertex can be opposite. So a right way is going to be a negative, and a left way is going to be positive. So kind of back to what you think. Here we have -4, which means we're going to go to the right 4. So from my vertex here, I'm going to go over 1, 2, 3, 4. That's my new vertex. And then we do the exact same thing. So if I go over 1, up 1 on my parent function, I'm going to go over 1, up 1 on this one. If I go over 2, up 4, I'm going to go over 2, up 2, or over 2, up 4, sorry. And then make my graph. Alright, so this is just a reminder that if it's outside of the x squared, it's up, down. If it's inside the x squared, it's left, right. Alright, now, here we're going to start talking about vertex form all together. Okay, so we have y equals 3, parentheses x minus 4, and parentheses squared minus 2. We want to know what's the vertex axis of symmetry, minimum or maximum value, and the domain and the range. So this one's asking for a bunch. So let's start with the vertex. All right. Now, you guys remember how to find vertex? It's the h, k values from one of the first slides. Well, the h is there, and remember the h is always opposite of what it says in there. So in there it says -4, so outside it's going to be +4. K value is going to be exactly the same as this one here, which is -2. Our vertex is at 4, -2. The axis of symmetry is going to be the h value, and it's going to be written as x equals h, and in this case it was 4. And these numbers here and here will always be the same. Next is the maximum or minimum value. Ooh, maximum and minimum. We haven't really talked about this, but let's think about it, what it means. A maximum or a minimum. Well, our two options for graphs are going to be either a U or a upside down U. Well, what we mean by this is is there a minimum value, which means is there a bottom of the bowl, or is there going to be a maximum value, which means is there a top of the hill? Well, to decide that, we need to look and say, hey, is this one facing up or down? If we look at the A value for that, the A value here is 3. It's a positive number, so it's facing up. So if it's facing up, there's a minimum value, all right? So the minimum value. The minimum value is there at the vertex, right? The minimum value is there at the vertex. And so when it's there at the vertex, what we really care about is just the y value. Because, right, we're talking about up, down. That's the y value. So the minimum is at -2. There is no maximum in this case because it keeps on going up and up and up forever. So it never gets to the maximum. It just keeps on going up and up and up. Last two is the domain and the range. Right. Domains are super easy for these ones because they're always all real numbers unless they tell you differently. Okay? Unless they say, hey, it can't be these numbers, unless it explicitly tells you. But it does not tell us any of that here. But if we look, this U, it's going that way a little bit, isn't it? It's going that way a little bit. If it's going that way a little bit forever, eventually it's going to hit all of the X numbers. And then a range. Well, range is going to start at the minimum value, which was -2, and it's going to keep on going until it gets up forever, right? Because we said there was no maximum. So I'm going to write this as -2 is less than or equal to y, which is less than or equal to infinity. All right? So it starts at -2 and it goes up. Right? It starts at -2 and it goes up. All right. Now let's talk about how to read vertex form. Okay? Basically, there's 3 pieces of information here. All right. 3 pieces of information there is K, H, and X. K is going to control our up, down. And that one works exactly like we think it is. Right? If it's a positive number, it's going up. If it's a negative number, it's going down. Exactly like we think it is. H is going to control our left, right. All right? But remember, it's opposite what you think. Which means if it's a negative number, it's going to be going to the right. If it's a positive number, it's going to be going to the left. And the A value controls our stretch and our compression, right, which means is it getting taller or wider. And also it controls our up, down. So those 3 pieces of information tells us everything we need to know. All right. Now we're going to be using vertex form to tell us what the graph of this looks like. Alright, so let me get a piece of graph paper in here. Okay. And let's do a few investigation for things first. So let's first off say, hey, where's the vertex? Right? Well, the vertex is going to be at 1, 3. Is it going to be facing up or down? Well, if we look at the a value, it's a -2, which means it's going to be facing down. And then, is it going to be a stretch or a compression? Well, that a value is 2, which is bigger, so it's going to be a stretch. Okay. So let's use these 3 pieces of information to graph. So vertex is 1, 3. It's 1, 3. It's a vertex. It's facing down, but now we just need to know how far they're going to go. Now, I'm going to show you guys 2 ways. One is written out, the other one is shortcut. So the written out way is I'm going to make an XY chart. Right. My vertex is at 1, so I need to do like 2 numbers to the side of it. So if I start at 1, the 2 numbers to the side of it are going to be like 2 and 3. So if I plug 2 into this formula or equation, I get 2 parentheses 2 minus 1 squared plus 3, which that's going to be 1 squared times 2 is -2. -2 plus 3 is 1. So it's going to be 2 is 1 right here. And then try 3, which is going to be -2. 3 minus 1 squared plus 3. And that's going to be, here it's going to be 2. 2 squared is 4. 4 times -2 is -8. -8 plus 3 is -5. So at 3 it's at -5. So it's went quite a ways. All right. And there we go. And you got it. Now it's symmetric, so I could graph this other half and just make it a mirror image. But I'm going to do it a shortcut way, just to kind of show you guys more than one way to do this. Now, the shortcut way is to say this is an x squared type of equation, right? So if I go over 1, I need to go down 1 squared. Usually down 1 squared. 1 squared is obviously 1. But now we're not going to be going down 1. We're going to be going down 1 times a value, so 1 times 2. So that 1 times 2 is 2. So I went 1 away from the vertex. So that's 1 squared times the a value, which is 2, which means I'm going to go over 1, down 1, 2. See how we got to the same place? Now let's try it again. If I go over 1, 2 from the vertex, all right, still using this x squared, that's 2 away from the vertex. That's 2 squared, which is 4. But we also have to times it by the a value. So the a value is 2. So we're going to be 4 times 2 is 8. So we're going to be going down 8 from here. If I go down 8 from there, it's going to be all the way to here. And that's -5, which is the same number, right? 2 ways. Do which one you feel more comfortable with. All right, now, what are the steps to perform the transformation from the parent function x squared to what we just graphed? All right. What they mean by this is they want to say, want you to describe how they've changed it, right? So you could say, we transform vertex. We went to the right 1 unit. Oops, 1 unit like that. And we went up 3 units. Okay. So that's pretty easy, right? I got that from here and here. Oh, that's not to the right, that's to the left. All right, to the left. My bad. I'm sure you guys caught me on that one, so that's good. To the left, 1 unit. Up 3 units. From there, what we need to talk about is, because we've talked about the h and the k values, we need to talk about the a values, right? There's 3 pieces to this. The a value. So that tells us it's flipped upside down, right? Which we just call that a flip. Right? So it's a flip and a stretch of 2. And that's what we need to do. I mean, we just need to say, hey, where did the vertex move to? And did we flip it? Did we stretch it? Did we compress it? And just give a good explanation of it. All right. Here we go. Here's problem 5. It's writing a quadratic function in vertex form. Now here we have a dolphin. He's jumping on that graph paper over there. And that's probably the prettiest graph paper you'll ever see. All right. So things that we need to know. We need to know the a value, h value, and k value. Right? So the easiest ones are h and k because we just need to look at the vertex. So if we look at the vertex, I think it's about right there. Yeah. About right there, which means the vertex is at 3, 7. Which means my h value is going to be 3. My k value is going to be 7. See how easy that is? Then the a value is next. If we look at the a value, first thing you should notice is a. It's facing upside down. That's a negative sign. Right? It's a negative sign. Now, next thing is, you can say is it stretched or compressed? It looks compressed to me. Right? But it doesn't quite know what's going to be compressed by now. I could take a good guess, but that's not exactly right. So what I'm going to do is, let me just go ahead and plug in what I have now so I can see what it looks like. Right? Let's call this one D of X, right? D for dolphin. Oh, and Davis, because there's a dolphin and a Davis in there. And then I still don't know my a value, so I'm going to leave that. And it's going to be x minus h. Well, h is 3, so x minus 3 plus k. Well, k is 7, so we get x minus 3 plus 7, and I need to remember to put in my x, my squared there, so it is a quadratic. But now we need to find out what a is going to be. The easiest way to find out what a is going to be exactly is by plugging in an ordered pair. Now, if I look here, I have an ordered pair there of 0, 6. 0 is my x value. 6 is my y value. And I could plug those in here, right? If I plug in 6 here for my y value, and then I have a, or not x, but 0 minus 3 squared plus 7. And then I have 0 minus 3 is negative 3 squared plus 7. Negative 3 squared is 9, so I get 6 is equal to 9a plus 7. And these are pretty easy to solve. So minus 7, I get almost over here. Negative 1 is equal to 9a. Divide by 9, divide by 9. And I get a is negative 1/9. Now, that one probably would have been pretty tough to just guess, but now we know what it is exactly. So a is, we already got that negative part. We already knew that, but now we know it's negative 1/9. Right? And then last step is just to plug it in to the equation, right? So I'm going to take out this a that we wasn't sure what it quite was. So I'm going to plug in negative 1/9. Now here is the equation. All right. With that, you guys should be armed and ready to go to do these homework problems right here. All right. So good luck, and ask me if you have any questions.